Hello students, today we are going to learn about some scientific reasons behind our everyday activities, and this main reason of this activity is only and only because of the evaporation process. See, we have learned that evaporation causes cooling. So just refer quickly. Evaporation is the process of converting liquid to vapor form. So, in day-to-day life, wherever there is an evaporation process, it causes the cooling in the surrounding. Why it causes cooling? During the evaporation process, see, water particles have some energy. They are moving. Okay, each and every particle is moving. So, in this state, in this moving state, they have some kinetic energy. But if they get energy from the surrounding, okay, by getting the energy from the surrounding, some of the particles who got that energy from anyhow, from the vessel or the wall of the container or atmosphere or air or anything, right? If they get this energy, some particles, that particles escaped from, they have more energy, so they escape from the remaining liquid state, and they they escape from the force, they break the force and throw out from the liquid matter, okay, and they are going into the surrounding in a vapor form. So this is the idea. The particles should get energy from surrounding, right? So this is how these particles are getting energy from the surrounding. So ultimately the energy of the surrounding becomes less because that energy is going into the particles, right? So if the energy of the surrounding is decreased, then we can say that that surrounding becomes cool. Okay. So this is the basic idea of the evaporation causes cooling, because the particles to evaporate, if the particles wants to evaporate, they need energy, and that energy is obtained from the surrounding. It can get the energy from any neighborhood, okay, from the surface, from the walls, from walls of the container or surrounding atmosphere, anything, right? Basic idea is they get energy to evaporate, okay, and if they get energy, the surrounding energy decreases and that becomes cool. So some of the reasons, basic idea we have seen, but we don't know the reason. So today we are going to learn the reason behind it. The reason is evaporation. First thing, your palm feels cold when nail remover is poured on it. Okay, nail remover, which is the scientific name of nail remover is acetone. Okay, so when this nail remover or perfume, anything, they if you are taking in your palm feels cool. Why it feels cool? See, this nail remover or perfume or anything, they are liquid. They have the ability to evaporation, but compared to water, the evaporation speed, the rate of evaporation is quite more in this nail remover. Or also you have heard that if you are keeping the nail remover open for some time, the nail remover bottle is empty now, because the evaporation is quite compared to water. Water evaporates but slowly. Okay? For different liquids, the evaporation rate is different. So this nail remover have more evaporation speed, right, at the same temperature as water. So, and they evaporate fast. If they want to evaporate fast, they get more and more energy from more and more particles are evaporating. So they get more and more energy from the surrounding surface. So when we are pouring onto our hand, the only surface they are having is our hand. Okay, so they take the energy from our body. Okay, so our surface, body surface gives the energy. The energy from our body surface is going into the nail remover, right? So basically, our body surface energy decreases, and our energy decreases. We feel there is a we feel cold. Right? So whenever the nail remover is added onto the palm, we are getting coldness due to the evaporation of nail remover. The nail remover particles are evaporating, by getting the energy from our palm, and ultimately our palm energy decreases. That is the reason we are feeling cold. Another thing we have seen it. People sprinkle water on the roof in hot summer day or anywhere in our on the tiles or on the roof. Why they are pouring water? Because on the hot summer day the temperature is quite large. Okay, so evaporation rate will be more. Now, whenever the water is sprinkled on the roof, the water evaporates. Okay, and roof is hot. The roof surface is very hot. So the water on the roof will take the energy from the roof surface, roof metal, it is made up of metal. So it takes the energy from the metal, from that surface and evaporate it. Okay, so more and more water will be evaporating and more energy will be taken from the roof surface, and ultimately the temperature of the roof decreases because the energy is going into the vapor to convert into vapor form. So the roof ultimately becomes cold, and it will be good so that we are feeling less hotness in the atmosphere if the roof is cold. Next, why should we wear cotton clothes in summer? See, our body in a summer, our body perspires more. Okay, more and more sweat is coming out from the body. Now, this water is not remaining in our body. This water evaporates, and why we are feeling cold. See, in the summer also, when we are completely sweating, we are feeling when the wind comes and we are feeling very cold. Why we are feeling that cold? Because whenever wind comes or anytime, whenever the sweat coming out of the body evaporates, that evaporation is taken place by taking the energy from the body surface. Okay, so water, the sweat will take the energy from the body surface and evaporates. So this makes that our body surface becomes cool, and we are feeling cool on the hot summer day whenever wind comes. And why cotton clothes? Because if the water wants to evaporate, so cotton clothes has the ability to absorb the water, and that water, the absorbed water will be exposed to atmosphere. The water particle will go into the atmosphere. So this is that's why cotton clothes are advisable to uh, take the water, to absorb the water. Whenever water will evaporate, it absorbs the water. Cotton clothes absorbs the water, right? And then exposed to the atmosphere. That's why cotton clothes are advisable. Now, why do we see water droplets on the outer surface of the glass containing ice? This we have seen, we can say every day or many times from our childhood. Because whenever we are taking ice cold water or ice in a glass, this outer side, ice is inside the glass, metal glass, okay, or any. So whenever ice is taken inside the glass, what we are saying, the outer surface of the glass, we are seeing it becomes the water is there on the outer side of the glass. Why we are seeing that water? It is not due to the evaporation process. See, whenever the what we can say, when the ice is in the glass, so the temperature of the glass is quite low, very less. So this temperature, this coldness, the surrounding will also becomes cool. The surrounding around atmosphere around the glass becomes cool. So if the temperature is cool, water vapor is available everywhere in the atmosphere. So the water vapor present around the glass gets the temperature is low, so that whenever the gaseous matter is cooled, it converts into liquid. So the surrounding water vapor, when the temperature decreases, that water vapor convert into liquid form. So that liquid and the glass surface uh, provides the surface for this condensation. See, gaseous to liquid, we are calling it condensation. So this condensation takes place on the surface of glass. So the surrounding water vapor around the glass uh, convert into liquid form due to the decrease in temperature, and that decrease is due to the glass, the ice present inside the glass. So due to this, the water vapor convert into liquid form, and that liquid droplets are around the glass. So this is the reason we see water droplets on the outer side of the glass. So this kind of very basic fundamental concepts we are seeing in everyday life, but the actual reason is very simple and deep too. Okay? So if you think, then you can get this basic idea and the actual reason um, behind the process we are seeing in our surrounding. So these are some of the reasons they can be asked in the exam also. Now, another thing we have seen in this chapter that the temperature, generally temperature is measured in, we are measuring the temperature into Celsius unit, degree Celsius, right? But there is another unit also for the temperature, that is Kelvin unit, capital K. Okay, K is for the Kelvin. Okay, like distance is measured in meter also and also in centimeter. Right? So there are many units for distance. Same way, the temperature is also measured in different units. Okay? So mainly the in our everyday life we are using in Celsius, but scientifically, the generally scientists use Kelvin unit to measure the temperature. Now, what is the relation between this Kelvin and Celsius? Right? The reason between Kelvin and Celsius is 0 degrees Celsius is equal to 273.15 Kelvin. Okay. 0 degrees Celsius is equal to 273.15 Kelvin, which is approximately taken as 273. Okay. So if you write 0 degrees Celsius is equal to 273 Kelvin, that is perfectly okay. And if you write 273.50, that is okay. But generally in this chapter we are using this 0 Kelvin to 0 Celsius is equal to 273 Kelvin. Then what about 1 degree? 1 degree Celsius. Okay, so we are adding 1 on the left side. 0 is equal to 273 Kelvin. So 1, when we are adding 1 on the left side. So same way we can add 1 on the right side. So 1 degree Celsius is equal to 273 plus 1, that is 274 Kelvin. Similarly for 2 degrees Celsius, 273 plus 0 means 273. So for 2, we have to add 2. So that makes 275 Kelvin. So 2 degrees Celsius is equal to 275, and it goes on. So ultimately what we are mainly have to remember, if we want to convert Celsius to Kelvin, Celsius temperature to Kelvin temperature, we have to add 273. And if we want to convert Kelvin to Celsius, then we have to subtract 273. Like it is given 300 Kelvin means how many degrees Celsius? So I have to Kelvin, I want to convert into degrees Celsius. So I have to subtract 273. So I am taking 300 minus 273, that is 27. So 300 Kelvin gives is equal to 27 degrees Celsius. 475 Kelvin to Celsius, I want to convert. So I am subtracting 273. 473 minus 273 is equal to 202 degrees Celsius. For 1000 Kelvin to Celsius, 1000 minus 273, that is 727 degrees Celsius. For 100 Kelvin, 100 minus 273. Remember here, I am subtracting bigger number from smaller. Okay, so smaller minus bigger, we are getting negative result. So minus 173 degrees Celsius, that is below 0, right? Negative temperature. And 0 Kelvin. So 0 minus 273, which will give minus 273 degrees Celsius. So this is quite low temperature. See, 0 degrees Celsius, water becomes ice. And below 0, that is minus 273 degrees Celsius. That is quite low temperature. And this is called the absolute zero temperature, 0 Kelvin. Okay, that is minus 273 degrees Celsius. So this is clear now how to convert Celsius to Kelvin, Kelvin to Celsius. Okay, so if the data is given in Kelvin, you can convert into degree Celsius. If the data is given into degree Celsius, you can convert into Kelvin. Only you have to remember here. Celsius to Kelvin, you have to add 273, and Kelvin to Celsius, you have to subtract 273. So these were the questions you had difficulty in the exercise, and so you can practice it at home, and if you have any doubts you can ask me. Thank you.